Okay, Rachel, let's put together what we've been learning so far and try to solve this example on, it's example 3 on page 451 of your book. Okay? So what have you been asked to do? You've been asked to find this distance, okay? And you've been given this original hypotenuse as 9. You've been given this as 3, and this y is what you've been asked to find. To me, this seems to be the second one of those theorems on geometric mean. If you remember, it involves the hypotenuse, it involves a leg, and it involves a portion of the hypotenuse that's adjacent to that leg. Remember? So really, you should remember right away that if you don't go back to the last portion that we just covered, okay, that the leg is geometric mean of two things: hypotenuse, original hypotenuse, and portion of hypotenuse, portion of broken or split, portion of the broken or the split hypotenuse adjacent to the leg. Okay? So the leg must be the geometric mean of the original hypotenuse, and then that portion of the split or broken hypotenuse that's adjacent to the leg, and that in this case is RS. Okay? So this in this case is equal to RS, and this in this case is equal to the original hypotenuse is RP, and you're looking for the leg, which is Y. So for me, it's very easy. So we remember the definition of geometric mean. You will write two fractions. Okay, we're getting ready to write two fractions. If we put the geometric mean right here, and the two things will go right here and right here. So the original hypotenuse is 9, and the portion is 3. What does this tell you? Can you solve this? That's saying y squared equals 9 times 3, which is equal to 27. Therefore, y equals square root of 27, which is equal to square root of 3 times 3 times 3. And you know very well that we can take the two 3's out of the square root sign, so that becomes 3 square root of 3. That's the answer. Okay? Now, notice that we have done this without even going back to draw the various triangles. That's done in your book. You can look at it. But in fact, if you recognize, and this is important for you to know this, if you recognize that the problem has to do with those two theorems on geometric mean, you can actually bypass drawing the three triangles separately, the three that come from this original drawing. You can avoid drawing them and orienting them if in fact the problem has to do with those geometric means, because you just have to remember, okay, remember that this is only one of the relationships that has to do with the geometric mean of the hypotenuse. What if they had switched it? If they switch that problem and call this x, I want you to find x. It's the same idea, Rachel. I hope you can see that. They may leave it this way, because with this whole thing being 9 and this being 3, you know that SP is 6. And that's the one you need in this case, because you're having the hypotenuse, it involves the hypotenuse, it involves a leg, but it must now also involve that portion of the original hypotenuse that's adjacent to this leg, and that is PS. That's why you need to know this. But you were only given this, but that's okay, because 9 minus 3 is 6. And then you just do the same thing. So again, the x you're looking for, and then you put the two things that make the geometric the geometric mean of which you are looking for, you are finding, in the x being the geometric mean. So that would be 9 and 6. So 9 and 6. And so in this case it will be x equals square root of 9 times 6, which is square root of 3 times 3 times 2 times 3, which is 3 times square root of 6. Okay, if I haven't made any errors. So the original problem we were given has to do with this leg, RQ. I have just modified it to show you that they could switch it around, and you have to involve this leg. Doesn't matter. There are two legs that work with that. The other theorem of the altitude. There's the theorem of the hypotenuse, which is this, and then there's the theorem of the altitude, the geometric mean theorem of the altitude, and that one will involve the altitude being the mean of these two portions. That one does not involve the hypotenuse. It will only involve RS and PS and the altitude. Okay? We'll cover that.